there's one, so light thermal water reactors are not the final answer. They are still going to lead us into trouble. The reason is that they only use a tiny amount of the uranium. 0.7% of the uranium that you mine is the uranium-235 that you want to use in those light water reactors. So they're only using a small fraction of the uranium. So these things are just not sustainable in the long run to the end of this century. So remember, we're talking on 60, 70-year timescales. How do you get out of that? There is a way out of it in the nuclear world, and that is you go to what are called fast fission reactors. These are breeder reactors, where from the uranium-238 you breed plutonium-239, and you use the 239 to actually give you your energy supply. And that means you can use up all the uranium-238, which is the other 99.3% of the uranium that's there. So you can use the uranium sometimes between 50, let's be conservative, more effectively than you're using at the moment if you develop fast fission reactors. And they, of course, require you to get this bred fuel out of them. Or you need a new fuel cycle, and that's popular in some countries, in India and in China. And there's a cycle you can base on thorium, and thorium is more abundant than uranium. So that would be good in taking you out beyond the lifetime of the uranium supplies. And then there's a thing I'm going to tell you a little bit about quickly at the end, fusion reactors as a way of getting this energy. Now, all of these require work, so it comes back to one of my other themes. We know how to do some of these things by using these other cycles and these other ways of doing things, but they aren't in production now. There's a lot of major R&D that has to be done to do it. So we've got to apply, you've all got to apply your minds to solving this problem. And it's one of the biggest problems that faces us on the planet. So let's just look at that for a moment, because I want to show you that some of those things are sort of possible, particularly on the fast reactors. When you run uranium through a cycle, through a nuclear fuel cycle, you go push it into this reactor, and out it comes spent fuel. The spent fuel you go and put in a hole in the ground, or you can reprocess it. If you reprocess it, you extract plutonium from it and the uranium-238, and you can go back into this, and you can keep going around this cycle for a long while. And that's the idea of the breeder reactors. They're not a fiction of people's imagination. Here I show you a picture from the north of Scotland, Dounreay, in Britain, in the late 20th century. There's a Dounreay fast reactor, which actually had worked from 59 until 1977. It solved an enormous amount of problems, because you have to use things like sodium, potassium, liquid metals to actually do the cooling. Or this one, more importantly, the prototype fast reactor, also at Dounreay, had a slightly different fuel, but was also cooled by liquid sodium. And that ran for 20 years, and particularly in the latter part of this time, it was delivering 250 megawatts of electricity onto the grid. So there are proofs of principle. You can do all of these things, but they haven't been deployed yet because people found cheap oil, lots of oil and gas, particularly in Northern Europe, and we didn't keep on following up on this. So now these things have gone past, they're all closed down. In France, I have to say, they're still doing quite a lot of work on fast reactors, and a jolly good thing that is too. Now, fast reactors and that process has another winning thing for you. This was the graph I showed you before of the light water reactor once through, where it was exceeding the amount of uranium we had. If you start to introduce fast reactors, and if you could do it in 2030, which is not very far away, but I believe in China they're trying to think in terms of starting deploying fast reactors at that point in time, and in India as well, then you start not to use up all of your uranium source. And so you turn over and you don't hit this problem. If you deploy the fast reactors later, you use these for longer, so you use up more of your uranium. So it's sometime in this period that you've got to have a fully functioning fast reactor fleet, just when the current new wave of thermal reactors come to the end of their lifetimes, their 50 or 60-year lifetimes. It has another benefit, however, and that is the spent fuel is no longer spent fuel. You keep reprocessing it to extract the stuff that you want to use again. And so actually, the worldwide spent fuel, which people do concern themselves with, is growing all through this period. But if you introduce a fast reactor fleet, you draw it, bring it down. So you don't have the same issues of disposal that of the quote, spent fuel, the waste from the reactors. So you have another benefit there, and that's the thing I think was long appreciated by the UK and also by France in Europe.